So, okay, now, yeah, so Martin, she joins. Okay, so what I will do is that let me give a quick recap of what we have done so far, and then we'll move on to, right. So let us recap what we have done. So first we solved, or we know that what is a vector. So a vector has two parts, right? The magnitude and the direction. So this hat represents the direction, and this is what? This is a unit vector. Okay, and this part tells us about the magnitude. Right. So if we want to calculate the unit vector from the vector which is given, so we just divide the vector by its magnitude, right? That will only tell us about the direction only. So let's say that we have this vector. So it has this tail part and this head. And this length is the magnitude. So this is A and this is A hat, right? So this is the geometrical representation of vectors. And then we studied that. Yes, hello, Martin. How are you? Yeah, so then we studied that we can write any vector in the form of Cartesian vector. So let's say we divide this in the X part and in the Y part and then in the Z part. So we can write any vector, right, whose position, let's say this is X, Y, and Z. So we can write any vector in the form of AXI plus AYJ and AZK. So this is one unit in the X direction, which is I hat. This is in the Y direction, J hat, and this is in the Z direction, K hat. So this we learned, right? And if we divide equal unit vectors in the X direction, so I, so if I write 5I, which means that I have moved 5 units in X direction. So this is my X component. Okay. And then I have, yeah, yeah, this is the Cartesian form of the vectors, right? Am I audible, guys? Hello?
Yes, sir.
Okay, so I thought that I'm talking to myself. Yeah, so this is the Cartesian form of unit vector. And then we also saw that if we have, let's say, two vectors, then we can do some operation on them, right? So the first was the resultant of vectors, right? Resultant of vectors. In Cartesian form, it is. So in Cartesian form, let's say if A is 3I plus 4J minus 3K, and B is, let's say, 2I plus 3J minus 5K. So A plus B is very easy in the Cartesian form, right? This would be simply 5I plus 7J and minus 8K. So doing getting the resultant in the Cartesian form is easy, right? So now we will talk about the resultant of vector in polar form. What is the polar form? Right. So when we have a vector, right, and its magnitude is given and its angle is given. So this is the polar form. And let's say that we have two vectors, right? We have two vectors. So this is one vector A and this is the other vector B. So what is given is that we have A vector and B vector and the angle between the vectors. So just remember that whenever we measure angle between the vectors, we measure between the two tails, right? So we just place those tails at the same point and then we measure the angle. So let's say if I am drawing a vector like this and another vector, let's say like this. Okay, so let's say like right. And if this is 60 degree, so what would be the angle between the vectors? So you see that this is the head of the vector and this is the tail. So I have placed this tail in here. So if I place that tail in that side, so this would be this, and this was angle 60. So this would be how much angle? This would be how much? So linear property. This is 60, so this would be 120. Okay. So this was about the angles measure. We always measure the angle between two vectors with two tails, right? So this was about the angle measurement, and then we saw that the resultant of these two vectors would be how much? So this would be, I will draw the parallel line to this B, right? And then I will draw a parallel line from this point, which is equal to this one. So this, right? So then I will get a parallelogram, and when I join the diagonal, so this will give me the resultant. Okay, so this will give me the resultant, and we will have the magnitude of this resultant. So this would be how much? This would be a square plus b square plus 2 equals to 2. This is the magnitude and direction is how much? This is b sine theta divided by a plus b cos theta. So this was about the result. Now what is the subtraction of the vectors? So this we also learned that we have this vector, right? A, and this is B. So what we do is that we take the opposite of this B vector. Right? Opposite of B vector would be this. So this is minus B. And then I add A and minus B. So then I will make a parallelogram and then I will add and this would give me A minus B. So just see that this is A plus B, right? And this is A minus B. Okay. And what is the magnitude of this subtraction? So this is A square plus B square minus 2ab cos theta. So this is the magnitude and the angle is how much? This is B sine theta and A minus. This we learned. And then we learned that what is the resolution of vectors. So in the last part, we learned that we can resolve any vector, right, in the form of the Cartesian. So we have this angle and we have this magnitude. So I can write the x component, which is ax, and this would be a cos theta, and vertical component ay, which is a sin. Okay. So then I can write my vector as axi and ayj. So this would be a cos theta I plus a sin theta j. So that is how we resolve the vector which was in polar form. This is in polar form and we have reduced it to the Cartesian. This was about the resolution of it. Okay, so any doubt up to this point, guys? Do you guys have any doubt up to this point? Yes, I guess there is no doubt. So in today's class, we'll be solving the question from the dot product and then the cross product. So first, let us talk about this dot. And this is also called scalar. And right. So we have two vectors, A, right, and B, and the angle between them. So the question is that what would be the dot product? So dot product is simply as the name suggests, product and dot meaning it is a scalar, right? So whenever we multiply two vectors and we get uh, a scalar, so that is called the dot product. And mathematically how it is represented, so this is A dot B and this is A B cos theta, right? And we saw that in the if the vectors are in the Cartesian form. So let's say that vector is AXI plus AYJ plus AZK and vector B is BXI plus BYJ and BZK. So A dot B would be simply 1. So before I do that, Rishita, you tell me that what is I dot I. This we have done, yeah, this we have done in the class. And if you guys, what is I dot I?
One, sir.
1, absolutely. Good. You remember. So I dot I is 1. And okay, what is I dot J?
2.
Yeah. Martin, what did you say?
Yeah, 2.
2. Okay, so Martin answer is 2. And Akib, what is your answer? Guys are not right. And Rishita, what would be the answer?
Zero, sir.
Okay, my voice is low. What? Rishita answer. My voice is low, guys. Rishita and Martin, can you guys?
Yeah, yeah, it's clear.
Yes.
My voice is low.
No, no,
Uh,
it's clear.
no, sir, it's fine.
Oh, so Akib, you check your earphones, micro, headphones, or whatever you are. Akib, okay. Akib also answered wrong. Yes, so majority says 0, right, Martin? So you see that why, what would be I dot J? I dot J would be magnitude, so from here, right? Magnitude of I, magnitude of J, and cos of, what is the angle between I and J, Martin?
90.
90, right? So cos 90 is how much? This is 1, and cos 90, this is how much?
Is 0.
Right? So this is 0 and multiplied with 1. So this so understood. So I dot J is similarly I dot K and similarly J dot I and something K dot I and whatever the scenarios are. So I dot I, it is equal to J dot J and it is equal to K dot K. So in dot product, just remember this one. Hello, am I audible, guys?
Yes, sir.
Okay, I think, yeah. Who is Abdullah Al Farasi? Yes, hello, Abdullah. Hello.
Yeah, yes.
Yeah, so Abdullah, you are here for the NEET and JEE class, right? So you are in Amna Map class, or yeah, you are in Amna Map class. Hello, Abdullah. This is your first class, right? Yes, Abdullah. Yeah. So okay, so yeah, and do you know about vectors? Any part of vectors? Yeah, are you familiar with vectors and vector operations? Okay, so okay, then it's good. Then okay, so only the I and I will survive. So the answer would be only AX, BX, AY, BY, and AZ. So whenever we have the Cartesian form, this would be the dot product. And whenever we have two vectors and the angle between them is given, right? So then this would be the dot. Okay. So then we'll use this, and for the Cartesian form, we will. This is the general formula, and this is the derived formula. Okay. And what is the use of this dot product? So this dot product is very useful in calculating the direction between the vectors. Direction between the vectors, and it is also important in calculating the projection of vectors. Okay. But from the physics point of view, what is the use of this dot product? So this is used to calculate the work done, right? Work done, which is F dot S and other components, right? Whenever the scalars are involved, so whenever two vectors are given and the product is scalar, so then in that scenario, this dot product is okay. So yeah, this was the use of the dot product. So let us talk about the projection of the vector. Okay, I have done it already, right, in the class. So I'm just revising, and let's say that if I have this A vector, okay, and this is the another vector. So what is the meaning of the projection? Projection meaning we project on some. So let's say these are two vectors, right? So this is A and this is B. And if I project this B on A, which means that I bring this vector B vector in this, right? So I have projected this vector on the side of this A. So this is called the projection. If I bring this vector in this direction, so this is called the projection. So I have already discussed that projection of B along A. So this would be how much? Right, this would be how much? So this would be A dot, let me write so this would be B dot A, and this is right. And if I want to calculate projection of vector A along B, so this would be how much? This would be A dot B hat divided by this, right? Because if I'm taking the projection of let's say this is A vector and this is B vector, and if I'm taking the projection of this B vector along A, so this now the B has come to this direction. So can you, Abdullah, can you tell me what would be the direction of B? Right, if I am taking the projection of B along A, so what would be the direction of B then? Along A. Yeah. Abdullah, what would be the direction of the projection of B along A? Yes. Okay, so you did not understand. Yeah. So I am talking about this, that I have this A vector, right? And this is another vector B, which is making an angle theta. So what I did there is that I am taking the projection. Projection meaning that I drop this B vector in this direction, right? So then this will have some component, right? This will have some component and the direction. So if I have taken it in this direction, so what is the direction of the projection there? Right. Just remember that this is vector here. So if I take the projection of B in this direction, so what is the direction of the projection? Rishita, yes, can you tell?
So K direction?
We're not talking about IJK, right? We don't know about, so until now we don't know about those universal net vectors, right? IJK. So again, if I tell you that this is A vector, so what is the direction of this A vector? Yes,
A A cap.
A cap, right? Good, A cap. And what I do is that I have this B vector and I bring this vector in this direction. So now what is the direction of this projection? Yes, this is in the direction of A, right?
Yes, sir.
So A hat is the direction. Okay. And this is the component of the B, right? So if I want to calculate projection of B, so this would be the component, right? And this would be the direction. Or if I tell you simply that if I bring this in here, so this would be B cos theta, right? So B cos theta, how can I write B cos theta? So I can write B cos theta, and this would be the direction. So any doubt about this projection? Any doubt about this projection thing? Yes, guys. Okay. So I guess, yeah, just remember that whenever I want to calculate projection of something along that, along, let's say B or A, So B would be then in the unit vector form and projection of this would be in the vector form. Okay. And a direction would be along whatever you want to calculate. So the direction would be B. Right. If I want to calculate along B, so direction would be B hat. Because along A, this is A hat, along B, if I take this A vector, so this is A, projection of A along B. So now the direction would be B hat. So B hat and A hat. This is the idea of the projection. Okay, and the last thing, okay, so what I will do is that I will just quickly tell you guys that, yeah, cross product. So I will just quickly write and then we'll solve the question. So cross product is what? Whenever I multiply two vectors and then I get another vector. Okay, so this is called the cross product. And what is the value of this cross product? So this is related by AB sine theta. And so you have in the left hand side you have a vector, and in the right hand side you have what? So AB sine theta is a vector or a scalar quantity. Okay. So AB sine theta is a scalar quantity or a vector quantity. Yes. Do we have anything which represents direction in this part? Yeah. Scalar quantity. Yes. Correct. Correct. Okay. So now we need also the direction because this part tells about the magnitude, right? So we will also need direction. So this we would be represented by this impact. Okay. And this completes the cross product. So this part is about magnitude and this part is about direction. And I will just write the cyclic thing that we use. So we have this I, this J, this K, and this goes like this. So whenever we calculate I cross J, so this would be K, and J cross K, so this would be I, and K cross I, this would be J. And if I, so this is what? This is cyclic, right? And if I do calculate in the anti-cyclic manner, right? So anti-clockwise, then I will get minus. So if I calculate I cross K, so this would be minus J. If I calculate K cross J, so this would be minus I. And J cross I, so this would be minus K. These are the relations. And I cross I, J cross J, and K cross K would be 0. So I have explained these things to you already. So we will not go into detail of, right. And how do we interpret the direction of n hat? So we have A, B, right? This is A, this is B. And whenever we want to calculate the direction of the cross product, so we use the Maxwell thumb, right? So we place our palm in the direction of A vector and then we move to the B direction. So you see that whatever your thumb points out, that would be the direction of the uh, n hat or the cross product. So you guys tell me that I have this A and B, and I have one another direction which is coming out of this plane, right? I have this plane and one direction is coming out of this plane. So that direction would be perpendicular to both A and B or not? Can you guys tell? Yeah, is that a direction perpendicular to both A and B? Yes, you can see it from here. You can see it from here that I have I and J. these two vectors, right? And if I take the cross product, so I will get k. And k is perpendicular. Yeah, so let me bring this here. So k is perpendicular to both I and so I have this one, right? I have this one. So I have this I have this j, and I have this k, right? So if I take the cross product, so I will get what? K direction, right? So I have this I and I have this j. So this k is perpendicular to both I and perpendicular to this j, right? So cross product will give you the direction which will be perpendicular to both the vectors. Is this statement clear to you guys? Yes, clear. Yes, guys, clear. Why you guys are so silent today? Okay, so now we know the dot product and cross product. Now let us do some question based on. So if you guys have any doubt, then you can ask me. And always remember that this dot product is very useful in finding the direction of the vectors, and it is also used in finding the projection of the vectors. Okay. Okay, so now let us come to this question, eighth question, right? So yeah, I have this vector A, and I have another vector B, and I want to calculate projection of vector A, projection of vector A along B. So this was what? Projection of A. So I will write A along B. So I will write B, and then the direction. Right. Clear, guys? So A is how much? A is I plus J plus K, and B is I plus J. So you guys quickly calculate and tell me what is B hat. What is B hat? Quickly calculate and tell. Yeah, you guys quickly calculate and tell me. So what is B hat? Yeah, so whoever has got the answer, please tell. Yes, any of you got the answer? Shiza, Akif, Martin, and Abdullah.
Yes, sir.
Yeah, what is the B hat? What did you get, Martin?
And do.
Yeah. Yes, guys, any of you, what did you get? This is unit vector, right? And the first thing I talked about is to calculate Yeah, calculate the unit vector from the vector, right? So how do we calculate the unit vector from the vector? Yes, guys have forgotten
Then
all the
I magnitude, then J, and then cos 60.
cos 60. No, 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 no. We are only talking about the unit vector, not the resolution.
Sir, I cap plus J cap.
I cap plus j cap. This is vector B, right? So, okay, so you guys, B is what? This is B and B hat, magnitude and the direction, right? Unit vector. So, unit vector is just vector divided by the magnitude, right? And what is the magnitude of this vector? This is simply root of 1 square plus 1 square. So, this is root of 2. So this is magnitude. So B hat would be vector B, right, divided by this magnitude. So I plus J divided by. Yes, so you guys remember now. Yes, here.
Yes, sir.
Okay, now we have B hat, we have A hat, so we can calculate the projection of A along B. So projection of A along B would be how much? This would be A dot B, right? Hat and B hat. So this would be I plus j plus k dot I plus j divided by root 2 and then I plus j divided by right. So this is the dot product. I dot I would be 1. So 1 by root 2 and j will survive. So 1 by root right. And then I plus j divided by okay, so this would be how much? 1 by root 2 and so this would be 2 by root, right? And then I plus j divided by root. So root to root 2 is 2. So 2 by 2 I plus j. So this would be simply I plus j. This is the answer. Okay, guys. So I plus j. Is that clear to you guys?
Yes, sir.
Yeah, so please note it down and if you guys have any doubt, you can ask. And let us, how much time do I have? 6:37. So I have, yes, I have time. And who got disconnected? So two people got disconnected. Oh, Akib and Abdullah got disconnected. Yes, so you guys quickly note it down and whenever you guys have noted it down, so please tell. Yeah, whenever you guys have noted it down, please tell. Done, guys?
Yes, sir.
No, I'm almost done.
Okay, 1 second. Please note it down. Okay, so Martin, whenever you have noted it down, please check. And you guys revise vector because vector is very important. Okay, so you guys forgot about the magnitude, right? Magnitude of, yeah, magnitude of, let's say, AXI, AYJ, and AZK. So this is root of AX square, AY square, and AZ square. So, yeah, you guys revise. Otherwise, you guys will forget. So noted, Martin.
Yeah, Francis.
Okay, so now let us solve the next question. Okay, so this is a printing mistake. This is A2, right? So we have magnitude of A1 is given and magnitude of A2 is given, right? And A1 plus A2 is given. This is also 5. Then we want to calculate what is 2A1 plus 3A2 and dot 3A1 minus 2A2. Okay, this we want to calculate. This is given and this we want to calculate. So you guys see, let us calculate this one first. So if I take A1 with A1, so that would be how much? Yeah, so let me explain this question here and so let's say I have this one. A vector which is AXI and AYJ and AZK. So whenever I take the dot product with the same vector, so what will I get? I will get AXI plus AYJ plus AZK and dot AXI, AYJ and AZK. Right. So if I take the vector product or the not the vector product, the dot product with the same vector, so you see that I dot I will survive. So this would be AX square and AY square and AZ square. This is how much? This is how much, guys? AX square plus AY square AZ square. This we already know. This is how much? So we have A, this is AXI, AYJ, and AZK. So if I take the magnitude of this vector, this is AX square, AY square, and AZ square. So if I square on both the sides, so this is A square, AX square plus AY square plus AZ square. Right, guys? So AX square, AY square, AZ square would be how much? Yes. A square, right? So if I take the dot product with the same vector, I get square of that vector. Understood? Clear? Okay. So yeah, similarly, if I take the dot product here, so 2a1 dot 3a1, right, plus 2a1 minus dot of minus 2a2 and plus 3a2 dot of 3a1 and minus of, let me directly write 3a2 dot 2a2. Okay. So you see a1 dot a1. So this would be a1 square. Right. This is minus 4 a1 dot a2. And this is 3 3s are 9 a2 dot a1 and minus of 6 a2 square. Right. Is this part clear to you guys? Yes. So I have a1 dot a2 and a2 dot a1. So this is commutative. So I can write a1 dot a2 as a2 dot a1 because this is commutative. So I can write that, right? So and remember, but a1 cross a2 would not be equal to a2 cross a1 because cross product is not commutative, right? So this would be 6a1 square minus 4a1 a2 and plus of 9a1 a2 and minus of 6a2 square. So this would be 6a1 square minus plus 5a1 dot a2 and minus 6a2 square. Right. So a1 we know, right? a2 we know. We don't know this a1 dot a2. Right, guys? Yes.
Yes, sir.
Yeah. So we have to find how can we get this a1 dot a2. But we have only this much information. This one, this one, this one. So how can we get a1 dot a2? Yes. Any idea, guys? Hmm. Any idea? Yes. So the idea is that we have to use because this right and this is the thing which was not used in any of these calculations. So we have to think somehow that how can we use this one? Okay, how can we use this one? So yeah, so let me write this. So a1 plus a2, right? This is and let's say that I want to calculate a1 and a1 plus a2, right? So this would be how much? This would be a1 square, right? a1 and then this would be a1 dot a2 plus a2 dot a1 and plus a2 square. So this would be how much? This would be, yeah, so this would be a1 square plus 2 a1 dot a2 and plus a2 square. And we already saw that what is same multiplied by same. So this is a1 plus a2 whole square, right? So this we know, which is 5 square, and this is how much? So this is how much? This is a1 square. So this is A1 is 3, right? So A1 is 3 square and plus 2 A1 dot A2 plus this is A2, which is 5. So 5 square. And this 5 cancels, and we have 3 square, which is 9, and 2 A1 dot A2. So A1 dot A2 is how much? This is minus 9 by 2. So from here we get the value of A1 dot A2 using this one. Using this one, we can get the value of A1 dot A2. So this was the missing link, right? So now we can plug in the value. So this is 6, 3 square plus 5, A1 dot A2 is minus 9 by 2, right? And minus of 6, 5 square. So this is 954 minus 45 by 2, and this is minus of 150, right? So 25 into 6. So this is 4, oh, this is how much? So 54 minus of this is 300, 45 plus 300 by 2. So this is how much? 345 by 2, which is 54 minus 172.5. So this is how much? 5, and 12 minus 4 is 8, and this is 6 minus 5, 1, so 118.1. This is the answer. If you guys have any doubt, then you guys please ask. If you guys have any doubt, please ask. Otherwise, please note down this problem. Okay, no doubt, so please note down this problem. What is this? This is mixing with, yeah. Yeah, you guys please note down this problem. If you if you guys don't have any doubts, so please note down. And this is the answer. So just remember that this was the crucial thing to calculate, right? So this was the only missing link, and we had to figure out that how can we calculate this one. Okay, so and this question came in JEE, right, in 2019. So and whenever you guys need me to scroll down the screen, you guys yeah. So whenever you guys need me to scroll down the screen, you guys tell. Yes, noted, guys.
No, no.
Oh, okay, okay, okay. Yes, yes, please, note.
Yeah, can you scroll down, sir? Yeah, can you scroll back?
Oh, which portion? Uh,
Yeah, before.
this one.
No, no, no. No, no. Go back down. Was there the continuation after?
Yeah, is this okay?
Yeah,
So whenever you have finished noting, please tell. Yes, noted, everyone. Yes, should I move on to the next question, guys?
I'm done, sir.
Martin, what about you?
no, I'm down.
Martin, you will have to quickly write it down, right? Otherwise, we'll be doing less questions.
Yeah, yeah, done, sir.
Okay, so let us quickly go on to the next question. Remember that whenever we want to calculate the angle, so then we need the dot product. And this question I have asked previously, and you guys have solved this problem, so let's see that you guys remember or not. Right. Okay, so just going down in the memory lane. What do we already know? So we already know that we have this ray, right? So this is acute angle, and this is right angle, and this is obtuse angle, right? This we already know, right? So keeping this in mind, let us Let us solve the expression. So the angle between two vectors, this one and this one is obtuse, right angle, acute, cannot say. Okay. So we have two vectors, right? -2i plus 3j plus k. So you guys quickly tell me what is the magnitude of A, and we have another vector which is 2i plus 2j minus 4k. So what is the magnitude of B? You guys quickly tell. Yes, guys, quickly calculate and tell me the answer. Yes, what did you get, guys? What is A? What is B? Rishida, okay, Martin, and Abdullah. I don't know where is Abdullah. So yeah, you guys. Yasir has not come today, and
Root
Abdul.
of 2 squared plus 3 squared
Yeah,
plus 1
root
squared
2 square, 3 square, 1. So this is 4, 9,
plus
1.
9 plus 1. Root of 26.
Huh?
Sorry, root of 5.
Oh, 40. So you got me confused already.
Sorry, root of 14.
Yeah, and this is 2 square plus 2 square plus 4 square, right? So this is 4 plus 4 plus 16. Ah, so you are telling me the answer of this part, right? Okay, so now we have B and we have A. So what is the use of A and B? Let's see. That what is A dot P then? B cos theta, right, guys? And we have also A in the unit vector form. So A is this and B is so minus 2i plus 3j plus k dot 2i plus 2j minus 4. And A is we calculated 14 and B is 24 and cos theta. So you guys see that this is why the dot product is important. And this is -2, 2, so -4 and this is 3 into 2, so 6 and -4. So this is root 14 into root 24 cos theta. Right. So this is how much? This is -8, so minus 2. And root 14 into 24 cos theta. So your cos theta is -2 divided by -14 into 20. So cos theta is negative. Okay. Now we want to answer this question that if it is obtuse, right angle, and acute, right? So if uh, right, so we have this quadrant. This is the acute one, right? This is the obtuse one. Right, so we are only talking about this side up to 180. So you guys tell me that if we are in the first quadrant, so what is the value of cos theta? Yes, in first quadrant, cos theta is positive, right? In second quadrant, cos theta is negative or positive? Yes, guys. because we know that in first quadrant all is plus. In second quadrant only sine and cosec is plus. The rest ones are negative. So cos is negative in the second quadrant. Is that correct, guys? Yes, understood. Rishta, Akib, and Martin.
Yes, sir.
So we are getting theta, cos theta to be negative, which means that it is lying in the second quadrant, which means that the angle is what? Obtuse. So this is the answer. If it is not clear, you can ask again, and if it is clear, then we'll go on to the next question. Yes, understood, guys. So if you guys have no doubt, you please note it down, and then we'll do this one. Then we'll do this problem. This we have already done, and this we have already. Oh, no, this we didn't do. So this question and this question we will keep it. You guys quickly note it down, and then we'll do the next question. Whenever you guys have noted it down, please tell.
I'm done, sir.
Okay. And Martin and Akib, what about you?
No, no, no,
Yeah, you have also written, Martin.
no, no, I'm almost
Oh,
done.
oh, okay.
You're done.
Okay, so now let us solve the next question. Okay, so this 76, right? The if a vector is perpendicular to the vector, then value of alpha. Right. So this is asking about the angle. So whenever the angle is involved, so we use the dot product, right? The angle between the vectors. Okay. So if the vectors are perpendicular, then what does it mean? So if the vectors are perpendicular, which means that theta is how much? Perpendicular theta is 90. So AB cos 90, right? Cos 90 is 0. So we have, so for two vectors to be perpendicular, their dot product is how much? Yes, guys. So for two vectors to be perpendicular, their dot product has to be 0, right? So now we will use this relation, and we have A, which is 2I plus 3J plus 8K dot 4J minus 4I plus alpha K. Okay, this is 0. So 2i and minus 4i. So much minus 8 and 3j into so 12 and plus 8 alpha. This is 0. So 12 minus 8, which is 4, plus 8d at alpha is 0. So 8 alpha is minus 4, alpha is minus 4 by 8, so minus 1 by 2. This is the answer. Okay, so yeah, there's no option. Alpha is minus. Any doubt in this question, guys? Yes, any doubt?
No, sir.
If guys don't have any doubt, so please note it down. And what I will do is that I will give the 79 question as your homework, and then we'll move on. So whenever you guys have noted it down, please tell. Yes, noted, guys.
No, I'm doing so.
Oh, yeah, okay. Got it. Yes, Martin, noted.
No, I'm almost done.
Ah,
Yeah, done, sir.
okay. So then this 79th problem is simple, right? So 79th is similar. So you guys take the screenshot of this question. Okay, take the screenshot of this question and yeah, so please take it as your home. This 79th question. Okay, guys, taken the screenshot.
So 79 question, right?
Yeah, this one. This one. So this one and this is not a bar, but this is hat. These are the direction. Okay, so this question and yes, did you guys take this screenshot? Done, guys?
Yes, sir.
Okay, and then yeah, so what is the unit vector perpendicular to this question we did. So, and also take this question as well. The second question. Two questions, right? You have 1 week and two questions on. So also take this as well. Okay. Yeah, and orthogonal means perpendicular. So that is why I am giving this question. Orthogonal means, let me write it in there. So orthogonal means perpendicular. Okay, so now let us come to this question. This 111 question. So the question is what is the unit vector perpendicular to the following vectors? So we have two vectors, A, which is 2I plus 2j minus k, and B, which is 6I minus 3j plus 2k. Okay, so we want to calculate what is the unit vector. First, let us forget this part. We want to calculate vector perpendicular to this one and this one, right? So how do we calculate the vector which is perpendicular to, oh, so which is perpendicular to this one and this one? How do we calculate that? A vector which is perpendicular to both. Yes, Rishita. We have two vectors. Okay, we have two vectors, and how do we calculate another vector which is perpendicular to this one and perpendicular to this one? So how do we calculate that vector? Any idea? Marte?
Yes, sir.
Yeah, so how do we calculate the vector which is perpendicular this one, this one?
So cross product.
Yes, absolutely right. Good. So yes, good. The cross product. If we take the cross product of these two vectors, right? So if we take the cross product of these two vectors, we get a vector which is perpendicular to both the vectors. Yes, good. So that is what I was saying. So first, let us calculate vector which is perpendicular to this one. So A cross B. This is perpendicular to both, right? This is perpendicular to both. And we want to calculate 2I plus 2j minus k cross 6I minus 3j plus 2k. So we have this cyclic group I, j, k, right? And this is the direction. So I cross I is 0. I cross j. I cross j is 6 minus 6k hat, and I cross k. So I cross k is minus. So minus of 2 2s are 4, and I k is j. Okay. And then 2j into I. So j into I is minus. So minus of 12, j into I is k hat. And what is left? So j into j is 0, j into k. So j into k is I, positive I. So j into k, which is 4 into 4, 2 into 2, 4. J into k is I. And then we have minus k and k into I. So k into I is j. So minus of 6 j. and then we have k into j. So k into j is negative. So minus minus and minus. So we have minus 3i. Okay, all the so I minus 3i. So this is I and j. So minus of 10j and 12. So minus of 18. This is the vector which is perpendicular to both. Right. Let's say this is C. Is that clear to you guys? Right. Is this clear, Rishita and Martin?
Yes, sir.
Now we want to calculate the unit vector. Right. So we have the vector. Now we can calculate the unit vector, right? So this C is how much? This is 1 plus 100 plus 18 square is how much? 324. Let me check that. So yeah, my memory is I think is that. So 320. So this is 324, 424, 425. So root of 425. Right. And this is not a perfect square, right? Is a 425 is a perfect square? So I guess it is not. 25 square is 20 square is 451, 20 is 400, 39 is 381, 37, 35 is not. Yeah, so I guess. Okay, so 35 square is how much? I guess that is 3. Huh? What did I do? Okay, what did I do? Why am I calculating 35 square? Okay, so 20 square is 400 and 19 is 389. So 425 is not a perfect square. So I have calculated the magnitude, right? And now let us calculate the unit vector. So unit vector would be C divided by C. So this is I minus 10j minus 8k divided by root of 425. This is the answer, guys. Is this clear to you, Shida and Martin? Or if you guys have any
Yes,
doubts?
sir.
Okay, so please note it down and then William. So you guys have two homeworks and yeah, please. Okay, this question was also important, but yeah. So in the next class, I'll start the average acceleration, average velocity, average speed. So these kind of topics I will in the next class. And whenever you guys have noted it down, please tell.
Right answer.
Okay, already noted.